About this, like how we should do. You can put that in the chat, or you can just turn on your mic and say this. Okay, so I guess no one. I'll give you just set 1 more minute. Just you can think of that. It might not be easy to like initially to just figure it out, but okay, I will just give you a hint. Okay, so just focus on this point. Just a second. Just focus on this point. All right, so I'm not hearing any answers, so I will okay, I will tell what the approach is. So AJ is basic AI modulo AJ. All right, so in that case, what do you observe? To maximize this value, what you have to do is you have to find the largest AJ value. AJ means the largest value that is actually present in the array. And you know that AI modulo AJ is equal to AI if AI is less than or AJ. No. Why does it happen? AI is equal to AJ into 0 plus AI. This is an observation that we have to make, because what happens is like if we sometimes what happens is we don't figure out these observations, and as a result we won't be able to figure like how to solve this problem. Generally, let me tell you that mostly in extreme and all, IEEE extreme and most of the coding competition sites and all, the first problem will be always an easy one, and mostly it will be based on number theory. So it's basically pure observation. There's no like hard theorems or anything that you need to apply. As I told, like number theory is a very vast topic, so even the problem setters won't go into a very large extent to like figure out. So this is an observation, okay? This is the proof for this. This is not a theorem, but yeah, you can just see it like AI modulo AJ is equal to AI if AI is less than AJ. Because it is like this, AI can be written as AJ times 0 plus AI. This is actually a famous lemma or a theorem we will discuss in the upcoming slides. So yeah, so where was I? Yeah, so we have to first find the largest. For AJ we have to find the largest element. So largest element, any number modulo largest element will be this one. I will again, observation number 2 is AI modulo AJ will be less than AJ minus 1, less than or equal to AJ minus 1, greater than or equal to 0. This is the observation number 2. I will just label it as. And one more thing, while solving a competitive programming problem or any problem that's based on your interview, make observations. You need not to jump onto the solution in your first attempt. Rather, you should slowly divide the problem into small segments and solve them individually. What happens is that some people, like even my former ICPC team also, what happened is like one of the teammate actually initially wrote a solution quickly, and he lost like he got a penalty for wrong submission. Then instead he didn't do any sort of debugging at all. And one more thing is, I haven't told, third observation is that they haven't told you like it's they have said that I is not equal to j, but they haven't told like the arrays in this problem, yeah, like the number elements in this array is distinct. So you can have a of I is equal to aj. It is not distinct. It may not be distinct. It is not mentioned that it is distinct. So there is a possibility that they might repeat. So what does ai modulo aj implies in that case it will be 0. Okay, so because like when you divide a number by itself, the remainder is obviously 0. That's so this is the third observation. Fourth observation is to maximize AI modulo AJ. Since you have to for AI will be like the second largest number. AI is equal to the second largest number. This property is actually from this one. You can correlate these properties. So we'll write the code right now. Using long for reading, like instead of int, I'm using long. Plus we read all these numbers. C++ has an inbuilt sort function, so we will use this. Then we will take the AJ value, which is the largest number, and we will assign answer to be 0. We will iterate from the second largest, like when you sort this, this is basically like sorting in ascending order, or like ascending. Let's compile this code. Now let's run this code. So I'll just take 5 numbers. So as I said, like 4 modulo 5 will be the answer over here. Now let's take some array that's having repeating numbers. What if every element is same? Get 0 as the answer, because largest value of any number is going to be like a largest and the smallest will be always the same. So answer will be 0. So this is the first problem to understand this. Always remember this topic. I mean, this concept is like this point will help you a lot in solving a lot of model related problems. This is an observation that you have to make. And for like observing this quickly, what you should do, you should solve more problems. So is there any doubt? Please feel free to ask if you have any doubt. Or like, is there anyone like whom I should explain this in Malayalam? So if you have any such doubts, you can ask, because like you can ask it now. Like later on, if I skip to any other slide or move any other slide, you won't be. Then it's hard to come back and just explain. So I assume that no one is having a doubt. It's nothing. Long story short, it's basically find the first largest number, then find the second largest number. If both of them are same, put answer is equal to 0, or else find the like calculate AI modulo AG. That's it. This is what I have done here. The complexity is, if you don't know what complexity is, I highly recommend that you should learn it. It's basically tells like it's n log n. N log n is basically for sorting, and remaining it remains as it is. So this is the highest, this is the function that gives the highest complexity. So we'll just work on big of n log n. So I assume that it's clear. And okay, yeah, next thing is like when you calculate a mod b is equal to m, and suppose if you have a is say negative number, This might be a bit confusing for some of you. Like if a is a negative number, okay, there's a small error in this program. I mean concept. What you have to do is okay, then add m to a till it becomes non-negative, and then do this. So, like if you have a non-negative number, I mean negative number, just add till it becomes a non-negative number and just do like divided by b in modulo it by b. Why I told to do this is it can actually sometimes what happens is if there is some tight constraint in the coding problem, what happens is that this may lead to a wrong result. For that you have to take care of this, but if you do this every time, this is always an and clean practice. I mean this will never go wrong. This will always give you the right answer. And some of the modular operations is a plus b modulo m is equal to a modulo m plus b modulo m the whole modulo m. So why is this you know in some problems as I told, like it exceeds the system's handling capability because it will give you a large result. So a plus b modulo m is not reliable. In that case, what you have to do is individually modulo this by m and add them, and then together modulo this by m. Like I will show and explain an example. And this thing, okay, this thing over here, this is something which is if you have I assume that like if you're from computer science, you will have a subject that is cryptography, and yeah, cryptography in your last semester, I guess. I mean second last semester, you will find this one, or like some insight will be given to this. So you and for multiplication also it applies the same. For minus, as I told, this you have to do. Then only you can like perform this one. And generally they don't ask you from minus because many there can be inconsistent result and a minus b is there. So we will just resort to this. And a by b modulo m, there is nothing like that. For that we have to find an inverse of that. And for finding the inverse, you need to have a knowledge of a theory called Fermat's theorem. And Fermat's theorem, assume that I cannot explain this in this given time frame. It will be a pretty large. It might not be. I would say that it's not the scope of what we are discussing right now. So I will explain this A modulo B thing. Why it require. Suppose like yeah, I will explain. Okay. So suppose you have to find the factorial of number n. So what happens is like for n is equal to 100 factorial and all, what happens is you won't get a smaller, like it will be more than 10 raised to 18. So for that case, what happens is I'll just initially compute I modulo m minus 1 modulo m. You can perform this in recursion as well. For those who don't know what recursion is, it is basically calling a function inside itself. I forgot over here is, oh, this is for 10 factorial. Now, what if I do like, this is the 100 factorial modulo 10 raised to 9 plus 7. 100 factorial is a pretty large number, but when we have to limit ourselves from into a very short range, we have to modulo this by 10 raised to 9 plus 7, and we are doing this over here. Okay, and one more thing you have to take care is, even though this will give you the same result, but when you print it also you have to do the same. Otherwise, what happens is sometimes even in your cout function, when you cout when you give a larger, again do a computation, then it can go wrong. So take care of this as well. So this is an example of how mod we can do. Okay, so this is basically a recurrence relation, like iterative relation we can say. You know that factorial of n is equal to, so that's what we have done over here. Just we will do, and again just we will totally mod this by, okay. So this is a concept that I wanted to explain using this one. Then I hope that's clear. If anyone is having any doubt regarding that, ആർക്കെങ്കിലും വല്ല സംശയം ഉണ്ടെന്നായിരിക്കും പറഞ്ഞില്ലേ? Okay, so I guess it's a no. Next thing is primes, generating primes. So I'll just, before I move on to primes, like I hope that everyone knows what primes are. Primes are those numbers which have only divisors, that number itself, and 1. So you can say like 3 doesn't have any other divisor like 1 except 1 and 3. And for 7, you don't have any other divisor like 1 and 7. The importance of prime numbers is like for encryption purpose and all, for cryptography and all, prime numbers are pretty much useful. And that's why there is an organization, I exactly don't remember its name, which actually pays you to find larger prime numbers, because generating primes is not an easy task, even though like almost like larger prime numbers like are not so like easy to find. Even there's a limit for our computers powers as well. So supercomputers are technically required for calculating large primes, and there are a lot of theorems, and even like prime number theory is also an active topic that's going on in the field of mathematics. There are like further researchers and all, like institutes like CMI and ISI Calcutta and all. They still focus on topics like prime numbers. Even MIT also have a separate, like in their mathematics division itself, they have a research area for prime numbers. Prime numbers is actually like, it's it's an unexplained phenomenon that happens in the nature, I mean the field of mathematics. So as I told, like what prime numbers are, one of the most common methods is is called the CFF error testness. Yeah, I know this name is pretty much complicated to pronounce. So we can just call it as prime sieve, okay? And this most of the coding problems that ask you to find prime numbers, they will limit themselves to sieve of error. There are plenty of applications or plenty of variations in this algorithm. Um, but generally, I'll explain the general algorithm. I'll explain the general algorithm. So initially, what you have to do is the logic is as follows. First, you have to create. I have just shortened this logic. I will just explain it in detail. Create an array of n integers. Like the limit up to which you want to find the prime. Like if you want to find the prime still 100, create an array of a size 100 plus 101 or 102. So then mark, yeah, you can put it like a Boolean array. You can say it as a Boolean array. It's true or false. Each they will contain a true or false. And you can mark, if it is prime, then you can mark it as like true or false, anything that's according to you. So mark 0 and 1 to be composite. We will assume here to be composite. In fact, 0 doesn't have any, like, we cannot say 1 is neither prime or composite. So and mark 2 to prime has 2 as prime, and from 2 is equal to from I is equal to 2 to I square is less than or equal to n. That is the limit. Perform the next operations. That is, for values I squared to n, mark all the multiples to be composite, and the remaining unmarked numbers says to be prime. Okay, so I think many of you might not have understood what it is. I will explain this in, you know, so basically, like, I'll explain this in Malayalam itself so that it becomes easy for you. ഫസ്റ്റ് നമ്മൾ എന്താ ചെയ്യുന്നത് വെച്ച് കഴിഞ്ഞാൽ ഒരു അറേ ക്രിയേറ്റ് ചെയ്യും. സപ്പോസ് നമ്മൾ പറഞ്ഞ ബൂൾ പ്രൈം എന്ന് പറഞ്ഞിട്ട് അറേ ക്രിയേറ്റ് ചെയ്യും. അതിൽ ലിമിറ്റ് എന്ന് പറയുന്നത് നമ്മുടെ ഇൻപുട്ട് സൈസ് n ആണെങ്കിൽ വിൽ ജസ്റ്റ് പുട്ട് സം n പ്ലസ് 10. ഇതിനെ നമ്മൾ ഇനീഷ്യലൈസ് ചെയ്യുന്നത് വല്ല ട്രൂ ഓർ ഫോൾസ് വാല്യൂ ആയിട്ടാണ്. ഓക്കെ, നമ്മൾ ഒന്ന് ഇത് ട്രൂ കൊടുക്കാം. എന്നിട്ട് നമ്മൾ ചെയ്യാൻ പോകുന്നത് പ്രൈം ഓഫ് 1 എന്ന് പറയുന്നത് ഫോൾസും, പ്രൈം ഓഫ് 2 എന്ന് പറയുന്നതും ഫോൾസും ട്രൂവും, പ്രൈം ഓഫ് 0 എന്ന് പറയുന്നത് ട്രൂവും കൊടുക്കാം. എന്നിട്ട് നമ്മൾ ചെയ്യാൻ പോകുന്നത് ഐ സ്ക്വയർ തൊട്ടിട്ട്, ഐ എന്ന് പറയുന്നത് 2 തൊട്ടിട്ട് അല്ലെങ്കിൽ 2 തൊട്ടിട്ട് ഐ സ്ക്വയർ n, ഇതാണ് നമ്മുടെ ലിമിറ്റ്. ഇതെന്താ സംഭവം? ഈ ഐ സ്ക്വയർ ഈസ് ലെസ് ദൻ ഈക്വൽ ടു n എന്താന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ, നമുക്കിപ്പോ ഒരു നമ്പർ തന്നു, സപ്പോസ് 24. ഇതിന്റെ ഫാക്ടേഴ്സ് എന്ന് പറയുന്നത് എന്താ? 1 2 3 4 6 8 12 24. ഇതാണ് നമ്മുടെ 24ന്റെ ഫാക്ടേഴ്സ് എന്ന് പറയുന്നത്. 24ന്റെ സ്ക്വയർ റൂട്ട് എന്ന് പറയുന്നത്, ഇത് ഐ സ്ക്വയർ ഈസ് ലെസ് ദൻ ഓർ ഈക്വൽ ടു എന്ന് പറയുന്നത് ഓൾമോസ്റ്റ് സ്ക്വയർ റൂട്ടിന് ഇക്വലന്റ് ആണ്. സ്ക്വയർ റൂട്ട് എക്സാക്ട് ആയിട്ടല്ല, ഇറ്റ്സ് എ ഫ്ലോട്ട് ഇന്റിജർ വാല്യൂ ഓഫ് ദി സ്ക്വയർ റൂട്ട്. സോ 24ന്റെ സ്ക്വയർ റൂട്ട് എന്ന് പറയുന്നത് 5ന് താഴെയായിരിക്കും. 5ന് താഴെ പറയുമ്പോൾ 4, നെക്സ്റ്റ് ഇന്റിജർ 4. അപ്പോൾ നിങ്ങൾ 24നെ 4 കൊണ്ട് ഡിവൈഡ് ചെയ്താൽ 6 ആണ് കിട്ടുന്നത് അല്ലേ? ഇവിടുന്ന് നിങ്ങൾ ചെയ്ത് കഴിഞ്ഞാൽ, ലൈക്ക് ഈ നമ്പറിന്റെ ശേഷം നിങ്ങൾ ഡിവൈഡ് ചെയ്യുന്നത്, നിങ്ങൾ 24നെ 4 കൊണ്ട് ഡിവൈഡ് ചെയ്താൽ നിങ്ങൾക്ക് ഇവിടെ 6 കിട്ടും. 3 കൊണ്ട് ഡിവൈഡ് ചെയ്യുമ്പോൾ 8 കിട്ടും. 2 കൊണ്ട് ഡിവൈഡ് ചെയ്യുമ്പോൾ 12 കിട്ടും. അപ്പോൾ നിങ്ങളുടെ കമ്പ്യൂട്ടേഷൻ അതേമാതിരി നിങ്ങൾ 6 കൊണ്ട് ഡിവൈഡ് ചെയ്യുമ്പോൾ 4 കിട്ടും, 8 കൊണ്ട് ഡിവൈഡ് ചെയ്യുമ്പോൾ 3 കിട്ടും, ആൻഡ് 12 കൊണ്ട് ഡിവൈഡ് ചെയ്യുമ്പോൾ 2 കിട്ടും. അപ്പോൾ നമ്മൾ എന്താ ചെയ്യുന്നത് വെച്ച് കഴിഞ്ഞാൽ, ഇവിടെ നമ്മൾ റീകമ്പ്യൂട്ട് ചെയ്യണം ഒന്നും കൂടി. അപ്പോൾ നമ്മൾ അത്ര ചെയ്യേണ്ട കാര്യമില്ല, നമ്മൾ ഈ സ്ക്വയർ വരയ്ക്കുള്ള കമ്പ്യൂട്ടേഷൻ എടുത്താൽ മതി. കാരണം ഈ റീകമ്പ്യൂട്ടേഷൻ പ്രിവെന്റ് ചെയ്യാം. ഇപ്പൊ നിങ്ങൾക്ക് n ആണ്, നിങ്ങൾ n-ന്റെ ഇതാണ് എടുക്കണമെന്ന് വെച്ച് കഴിഞ്ഞാൽ n വരയ്ക്ക് നിങ്ങൾ ഇറ്ററേറ്റ് ചെയ്ത് പോവുകയാണെങ്കിൽ നിങ്ങളുടെ കോംപ്ലക്സിറ്റി പറയുന്നത് ബിഗ് ഓഫ് n ആവും. ബിഗ് ഓഫ് n എന്ന് പറയുന്നത് n ഈസ് ലെസ് ദാൻ ഓർ ഈക്വൽ ടു 10⁻⁷ വരയ്ക്കും അത് വാലിഡ് ആവത്തുള്ളൂ. n 9 ആകുമ്പോൾ അത് ടൈം ലിമിറ്റ് എക്സീഡ് ആവും. അതേസമയം സ്ക്വയർ റൂട്ട് ഓഫ് n കോംപ്ലക്സിറ്റി വരയ്ക്കുക കാൽക്കുലേഷൻസ് ചെയ്യുന്നെങ്കിൽ അത് ഇതായിരിക്കും എൻ്റെ കോംപ്ലക്സിറ്റി. ആൻഡ് അതെന്ന് പറയുന്നത് ഈവൻ 10⁻12 വരയ്ക്കും വാലിഡ് ആണ്. ഇൻപുട്ട് സൈസ് അത്ര വലുതാണെങ്കിൽ വരയ്ക്കും അത് കമ്പ്യൂട്ട് ചെയ്യും. പക്ഷേ നമ്മൾ 10⁻12 വരയ്ക്കും പോകുന്നില്ല. ബിക്കോസ് ഇതിൽ നമ്മൾ ഈ അറേയുടെ സൈസ് എന്ന് പറയുന്നത് C++ എന്ന് പറയുന്നത് 10⁻6 വരയ്ക്കൊക്കെ പറ്റത്തുള്ളൂ. അത് കഴിഞ്ഞാൽ അത് ലിമിറ്റ് ഉണ്ട്, ബട്ട് സ്റ്റിൽ 10⁻6 വരയ്ക്കാണ് സാധാരണ എല്ലാ ക്വസ്റ്റ്യൻസിനും ഉണ്ടാവുക. സോ നമ്മൾ എക്സ്പ്ലെയിൻ ചെയ്യാൻ എന്താ ചെയ്ത് വെച്ച് കഴിഞ്ഞാൽ എല്ലാ നമ്പറും ഫോർ i is equal to 2 to i² is less than n, ഇതിൽ നമ്മൾ ഫോർ j is equal to i² എന്താ വെച്ച് കഴിഞ്ഞാൽ ലൈക്ക് സപ്പോസ് 100 വരയ്ക്കാണ് കമ്പ്യൂട്ട് ചെയ്യുന്നത്. 2 തൊട്ട് 2ന്റെ സ്ക്വയർ പറഞ്ഞാൽ 4 ആണ്. അപ്പോൾ ഇതിന്റെ ഇടയിൽ ഏതൊക്കെ നമ്പേഴ്സ്, ഇതിൽ എന്താ വെച്ച് കഴിഞ്ഞാൽ 4 കഴിഞ്ഞ് കഴിഞ്ഞാൽ അതിന്റെ സബ്സിക്വന്റ് മൾട്ടിപ്പിൾസ് വന്നത് 2ന്റെ മൾട്ടിപ്പിൾസ് വന്നത് 6, 8, 10. അപ്പോൾ നമുക്കറിയാം 2 പ്രൈം ആണെങ്കിൽ 2ന്റെ സ്ക്വയർ ഒരിക്കലും പ്രൈം ആവത്തില്ല. ബിക്കോസ് അതിന്റെ ഡിവൈസ് മോർ ദാൻ 2 ഡിവൈസസ് ഉണ്ട്. അപ്പോൾ 4 ആവത്തില്ല, അതിന്റെ സബ്സിക്വന്റ് മൾട്ടിപ്പിൾസും ആവത്തില്ല. 8ഉം 10ഉം അതൊന്നും ആവില്ല. അപ്പോൾ ഇതൊക്കെ നമ്മൾ ഫാൾസ് ആയിട്ട് മാർക്ക് ചെയ്യാം. സോ അതിന് ഇങ്ങനെ സബ്സിക്വന്റ് മൾട്ടിപ്പിൾസിനാണ് ഈ j+i കൊടുത്തിരിക്കുന്നത്. അതിന് വേറൊരു സംഭവം ഇതുണ്ട് ഇവിടെ. ഇഫ് ഇനീഷ്യലി നമ്മളെല്ലാം ട്രൂ ആയിട്ടാണല്ലോ സ്പെസിഫൈ ചെയ്തിരിക്കുന്നത്. സോ ഇഫ് പ്രൈം ഓഫ് i ഈസ് ഈക്വൽ ടു ട്രൂ, ഈ ട്രൂ ആണെന്ന് വെച്ച് കഴിഞ്ഞാൽ പ്രൈം ആണ് എന്നാണ് അർത്ഥം. സോ പ്രൈം ഓഫ് j ഈസ് ഈക്വൽ ടു ഫോൾസ്. ഇവിടെ കൂടെ കൊടുത്താൽ മതി. ഇത് പ്രൈം ഇങ്ങനെയാണെങ്കിൽ ഇങ്ങനെ ചെയ്യാം. അപ്പോൾ ഇതിൽ നിങ്ങൾ സബ്സിക്വന്റ് മൾട്ടിപ്പിൾസ് എല്ലാം ഫാൾസ് ആയിട്ടായിരിക്കും ഇരിക്കുക. ആൻഡ് ഈ ട്രൂ പറയുന്നത് ഏതൊക്കെ പൊസിഷൻസിലാണോ ട്രൂ ഉള്ള ആ പർട്ടിക്കുലർ നമ്പേഴ്സ് ഒക്കെ പ്രൈം ആയിരിക്കും. സോ ഇത് ഞാൻ ഒന്ന് ജസ്റ്റ് ലെറ്റ് മീ ഇംപ്ലിമെന്റ് ദിസ് റൈറ്റ് നൗ. ഞാൻ മലയാളത്തിൽ എക്സ്പ്ലെയിൻ ചെയ്യാൻ കാരണം എന്താ വെച്ച് കഴിഞ്ഞാൽ ഇതിന്റെ ഡോക്യുമെന്റേഷൻ അത്ര ഒരു ക്ലിയർ ആയിട്ടുള്ള ഒരു ആക്യുറേറ്റ് ആയിട്ടുള്ള ഒരു ഇതില്ല. ചിലപ്പോൾ അത് ചിലർക്ക് കുറെ പേർക്ക് മനസ്സിലാവില്ല അത് എന്താ സംഭവം എന്ന്. അത് കാരണം ഞാനിവിടെ ബോൾ ഉപയോഗിക്കുന്നില്ല. ഞാൻ അല്ലെങ്കിൽ വേണ്ട, ബോൾ തന്നെ ഉപയോഗിക്കാം. ഞാൻ ഇനീഷ്യലി ഇതിനെ എല്ലാം ട്രൂ ആയിട്ട് കൊടുത്തു. സീറോ ഇതല്ലല്ലോ, പ്രൈം അല്ല. 1ഉം പ്രൈം അല്ല. i² is less than n. ഈ സംഭവം ഓർമ്മ വയ്ക്കണം. ഇത് കുറെ പ്രോബ്ലംസിൽ ഇത് യൂസ് ആവും. ഇഫ് പ്രൈം ട്രൂ, നമ്മൾ ഇതിൽ ഇങ്ങനെ കണ്ടീഷൻ എഴുതേണ്ട കാര്യമില്ല. C++ തന്നെ അറിഞ്ഞോളും ഇത് എങ്ങനെയാണെന്ന്. i² തൊട്ടാണ് ഇറ്ററേറ്റ് ചെയ്യാൻ പോകുന്നത്. i² ഒരിക്കലും i പ്രൈം ആണെങ്കിലും i² ഒരിക്കലും ഇതാവത്തില്ലല്ലോ, പ്രൈം ആവില്ലല്ലോ. ഓക്കെ, സോ 100 വരയ്ക്കുള്ള പ്രൈം നമ്പേഴ്സ് നമ്മൾ ജനറേറ്റ് ചെയ്തു. ഇതിൽ നമ്മൾ പറഞ്ഞ മാതിരി 2 3 5 ഇതിന്റെ ഇടയിൽ കണ്ടോ, ഇപ്പോൾ ടൂവിന്റെ സ്ക്വയർ പറഞ്ഞാൽ 4 ആണ്. അപ്പോൾ ടൂവും ഫോറിന്റെ ഇടയിലുള്ള എല്ലാ നമ്പേഴ്സിനെയും നമ്മൾ ട്രൂ ട്രൂ എന്ന് പറഞ്ഞാൽ അത് അവിടെ സ്റ്റേറ്റ് മാറുന്നില്ല. പ്രൈം ഓഫ് ഐ എന്ന് പറയുന്നത് ഇറ്റ് റിമെയിൻസ് ആസ് ഇറ്റ് ഈസ്. സോ നമ്മളെല്ലാം സ്ക്വയർ വെച്ചിട്ടാണ് മാറ്റുന്നത്. ഇപ്പോൾ 5 തന്നെ 25 ആണ്. 25ന്റെ ഓക്കെ, നമ്മൾ അങ്ങനെ അതിന്റെ അടിയിലെ എല്ലാ ഈവൻ നമ്പേഴ്സും മാർക്കാവും. ബിക്കോസ് ടു ഇവിടെ ഉണ്ട്, ടൂവിന്റെ ഈവൻ നമ്പേഴ്സ് എല്ലാം മാർക്കാവും, ത്രീയുടെ മൾട്ടിപ്പിൾസും മാർക്കാവും. പിന്നെ 5 എന്ന് നോക്കുകയാണെങ്കിൽ 5 അതിലുള്ള അടിയിലുള്ള ഏതൊക്കെ നമ്പേഴ്സ് ആണോ, 5 എന്ന് പറഞ്ഞാൽ 25 തൊട്ടുള്ള 25 30 എല്ലാം അതേമാതിരി മാർക്കാവും. സോ ഇതാണ് സംഭവം. ആർക്കെങ്കിലും മനസ്സിലാകാത്തവരുണ്ട് ഇത്? ഇസ് എനിവൺ ഹു ഡിഡ്ന്റ് അണ്ടർസ്റ്റാൻഡ് ദിസ്? ബേസിക്കലി ഇത് മലയാളത്തിൽ പറയാൻ കാരണം തന്നെ ഇത് ഒരു ഇതല്ല, ലൈക്ക് പെട്ടെന്ന് ക്ലിയർ ആവുകയൊന്നുമില്ല. എനിക്ക് പോലും ഇത് ഞാൻ ആദ്യം തുടങ്ങിയപ്പോൾ എനിക്ക് അത്യാവശ്യം കുറെ ടൈം എടുത്തു സംഭവം മനസ്സിലാക്കാൻ ഇത് എന്താണ്. ഓക്കെ, സോ ഐ ഗസ് ഇറ്റ്സ് എ നോ. ഓൾറൈറ്റ്. So time complexity is n log of n. That's the advantage. Limitation is segmented C. Segmented C is a bit higher order topic. It's basically like you have this C, you just divide the array into segments, like different parts, and just apply the same operation like this thing. And complexity is n log n. It's not n log n, it's n log n. Because if it's log has a result, it's gives a better performance. But the only issue is like the space, like only up to 10 raised to 6 only you can generate. You cannot generate more than that. And one more advantage is like using this logic is for like companies like TCS, Infosys and all, they don't ask you in technical interviews and all, like face-to-face or video interviews, they don't ask you to find like harder problems. They just ask you like find prime numbers and those things and all. So in such cases, like you can use this. What happens is generally your logic, conventional logic is like for I is equal to 2 modulo I is equal to 0, return false. And this is basically like we check for prime, and we will conventionally, and then for each number we will just check if it is prime. Like let's say like it's the logic, like initially നമ്മൾ എല്ലാ നമ്പേഴ്സിനെയും ഈ ലോജിക് കൊണ്ട് ചെക്ക് ചെയ്യും, പ്രൈം ആണോ ഫാൾസ് ആണോ പറഞ്ഞിട്ട്, ഐ മീൻ പ്രൈം ആണോ അല്ലേ പറഞ്ഞിട്ട്. ബട്ട് ദിസ് ലോജിക് ഇസ് ലൈക്ക് ടു മെയിൻ സ്ട്രീം, ഐ വുഡ് സേ. ലൈക്ക് ഇറ്റ്സ് വെരി മച്ച് കോമൺ നൗ ഡേയ്സ്. ഇതാരും ഉപയോഗിക്കാറില്ല ഇൻ ദി ഫസ്റ്റ് പ്ലേസ്. നമുക്ക് കോളേജിലൊക്കെ പഠിപ്പിച്ചു തരുമ്പോൾ ഇങ്ങനെ ആയിരിക്കും പഠിപ്പിച്ചു തരിക, ലൈക്ക് പ്രൈം ചെക്ക് ചെയ്യണമെങ്കിൽ 2 തൊട്ട് n വരേക്കും പോകണം. പക്ഷെ കോമ്പറ്റേറ്റീവ് പ്രോഗ്രാമിംഗിലെ കോഡിംഗ് ഇന്റർവ്യൂസിലൊന്നും ആക്ച്വലി ദേ വോണ്ട് ആസ്ക് ദിസ്. കാരണം അത് ഇറ്റ്സ് കാരണം ബേസിക്കലി കോമ്പറ്റേറ്റീവ് കോഡിംഗ് എന്ന് പറഞ്ഞാൽ നിങ്ങളുടെ ആൽഗോറിതംസിന്റെ നോളജ് ഒക്കെ ചെക്ക് ചെയ്യാൻ വേണ്ടിയുള്ള ഒരു സംഭവമാണ്. അതിൽ നിങ്ങൾക്ക് ഇങ്ങനെ ഒരു പ്രൈം നമ്പേഴ്സ് ജനറേറ്റ് ചെയ്യാൻ അങ്ങനെയൊന്നും ചോദിക്കത്തില്ല. ഇവൺ IEEE എക്സ്ട്രീമിൽ പോലും കുറച്ചും കൂടി അഡ്വാൻസ്ഡ് ആയിട്ടുള്ള ക്വസ്റ്റ്യൻസ് ചെയ്യണം. ആൻഡ് ബിക്കോസ് അപ്പൊ ഞാൻ ലൈക്ക് ഇൻ മൈ എക്സ്പീരിയൻസ് ഗൂഗിൾ കിക്ക് സ്റ്റാർട്ടിലൊക്കെ സംഭവം എങ്ങനെയാണെന്ന് വെച്ച് കഴിഞ്ഞാൽ ലൈക്ക് they won't ask you direct logic. You have to apply these kind of algorithms. Next thing, another primality test. Primality test, like there are a lot of primality tests, deterministic and non-deterministic. You need not to worry about these jargons like deterministic and all. Just it's like there are tests like Miller-Rabin primality test and all. These are basically like it's basically a prediction wise primality test. Primality means you have to just check whether it's prime or not. Same logic on it. Like given input is 1, return false. It is true. If it is true, then return true. Like what I mentioned over here. Pseudocode for what I have mentioned. This is the primality test. Like I can write a function like Okay, so yeah, I'm not running this again because we have already discussed this right now in this one. That's now Euler's Eulers. Okay, so this is not Euler's. Pronounce it as Eulers. Euler's transition function is basically like it's also called as phi function. It counts the number of integers between 1 to n, which is co-prime to n. Co-prime means their greatest common divisor or HCF is 1. So you can just take a screenshot of this, okay? If you want to, like, if p is prime, then p minus 1, uh, p raised to k, and p raised to k minus 1. Like if k is like, um, this is the basic theorem. You just need to memorize this. If you go for the proof, it's going to be a lengthy, job. So just remember these things. And the code is similar as such, like the only difference is like divide every number by, like, you find this, we check this number, right? And modulo I is equal to 0, just divide this, like, do this continuously and find, like, add it to the result. That's what you have to do. So it's generally they don't ask questions from Euler torsion function, but I feel that it should be required because like in your exams also, like in your syllabus, this thing is there if you're from computer science. This one, Euclid's algorithm for computing GCD, one of the most important things in number theory. GCD or HCF is the largest number that divides two numbers A and B. Logic, GCD of A and B is less than or equal to minimum of A and B. Euclid's lemma. I am sure that, like, everyone should might have learned this. Even if you don't remember, that's, you need to remember this, recollect this. In your 10th standard, you will have this topic: A is equal to BQ plus R. Even in the first chapter itself, it is there. So A is the dividend, that's B is the divisor, and dividend can be represented as the product of divisor and dividend plus the quotient. No, I mean divisor and the quotient plus the remainder. So A mod B, the remainder will be A minus B into floor of A by B. Floor means flow function, like A 5 by 3 gives you like 1.667. Floor A by B means 5 by 3 will give you 1, because you remove that 1 plus 0.66 part. We can make a recurrence relation. Recurrence relation, for those who don't know, like recursion, it is like okay, just remember this right now. It's a pretty long explanation. You can, if you don't know what Euclid's lemma is, I would suggest to just revise it back. I will just explain how we compute the GCD, because we have time constraint as well. So I need to cover up everything as well. Conventionally, C++ does have a function for calculating GCD. Like, this is the function. Make sure that both the data types A and B are same. Like if it's long, put it long. Otherwise, it will show some errors. So you can use this one, but I will explain the logic behind this. If B is equal to 0, return A. Why? Because, like, okay, I'll explain it. 25. Suppose you have to find 25 and 10, right? Like 25 is equal to 10 into 1. Okay, 25 is equal to 10 into 1 plus 10 into 2 plus 5. In the next step, you have to find this 10 is equal to 5 into 2 plus 0. In the third step, you have to find 2 is equal to, yeah, 5 is equal to, okay, for any value of k, it will still give you the, okay, yeah. Okay, yeah, sorry. Sorry, folks. Yeah, this is the limiting condition. Like if remainder is equal to 0. So you can see that in every step, what we did was the remainder, I mean the divisor over this becomes the dividend on the next step, and the remainder becomes the remainder. So that's, and when it becomes zero, we return this. Yeah, the next step, what happens is when the final step, A becomes 5, B becomes 0, and we don't write a relation for that. It's an invalid relation. This is the base case. If B is equal to 0, then return A, else return. Okay, so B. A pretty simple relation. You need not to, apply, think too much on this. You can use a conventional GCD function, but I recommend this to learn because it has a, you know, even in your interviews itself, what happens is they will ask you questions based on this. They can, but I am not sure, but it's, yeah. Okay, you saw that it's 5 because yeah, 5 is only like divisible by which can divide both 25 and 10. There's no other number that can divide it. You can do your conventional logic as well, like, but that's not going to work in most cases. Bezout's identity. I would highly recommend that you should have a look onto the this this resource over there. You have to solve a lot of problems on this to understand this, otherwise you won't. And yeah, I would suggest that Brilliant is a pretty good website to learn number theory, and even like for if you're for preparing for any math contest or any math olympiads, even though the math olympiads for college students are less, but still if you're interested for any of this, you can refer to Brilliant. It's a pretty good site for number theory, learning number theory and mathematical concepts. Okay, so that's all for our number theory part. Combinatorics, mostly we have inclusion exclusion principle, and I'm sure that in your 11th standard, if you're taken maths as your subject, you would have, okay, in your 11th standard, you would have studied this um, inclusion exclusion principle. This is a very common thing. And also, like when you're preparing for your placements and all, your institute will provide you a placement area, placement training in which they will make you like understand this what it is. Inclusion exclusion principle. I will make you explain it using Venn diagram. Same thing, S like A union B union C is equal to S of A plus S of B plus S of C minus S A intersection B, S of A intersection C and S of B intersection C plus A intersection B plus A intersection, like A intersection B intersection C. S can be any function that is related to this. This is the like the statement. This is the official, not the official, formal definition we can see, or the mathematical definition of inclusion exclusion principle. Suppose you have to find all the multiples of find all the numbers between 1 to 100 that are either multiples of 3 or multiples of 5. You can use this concept. You can just write it like S of 3 or 5 to be like S of 3 plus S of 3 and 5. That is LCM of 3 and 5, that is 15. So you can do this to solve such problems. There is nothing much about to say about inclusion and exclusion principle. This is a pretty easy topic, and it's pure observation. As I said again, it's purely observation. You have to create a mathematical thought for solving such problems. Binomial coefficients again, NC0, NC1, definitely permutations and combinations. You might remember these things. So this is a pretty easy way to calculate. NCK. And rather than like computing n factorial, then computing k factorial and n minus k factorial, you can do this for calculating this value, and this will give an around like an exact value. Exact precision is possible with this. So I add this code over here. And there are other things like binomial coefficients and dynamic programming. Basically, what happens, in combinatorics, they will ask you questions from DP, dynamic programming. And dynamic programming is not an easy topic. You have to master. For mastering DP, you need to solve tons of problems. I will just put some resources over here. You can solve, okay, just a second. Oops. Yeah. Codeforces.com, it's a pretty good site. The main advantage of learning through Codeforces is it's a Russian site, and a lot of like problem setters are mostly Chinese or Russians. And Russian site, in a sense, the site is owned by Russians, and they have a pretty good variety of problems. For practicing number theory, I can just do one thing like, since I assume that everyone is a beginner over here or like have only some intermediate level experience in this. Yeah, one more thing which I want to say is like there is another problem in like number theory that is called as Chinese remainder theorem. Yeah, just a second, guys. Yeah, so yeah, this is the Chinese remainder theorem. That's one of the most renowned, I would say, like theorem in number theory. So you should for that also you can check that in Brilliant, because you need to do a ton lot of problems in that as well. So for basic number theory, you can just go on to this one. Link basically gives you a 800. 800 is the lowest rating in code forces. So if you do a lot of problems in that, you can. I'm sure that yeah, you will get a good grip on these problems. And number theory is not something that you know. It's not a approach that you can actually you have to be like there should be some intuition while solving these problems. So there is something that's called as constructive algorithms. This will also have some math. So you can just have a look onto this as well. So that's number theory. And for combinatorics, I'm not giving anything. So for number theory, yeah. So for combinatorics, again, observation is the key. Like you are given an array of n integers, you have to find whether two numbers, like if count the number of pairs that's having odd sum. So for finding odd sum, you have to find like count number of odd integers that's present in the array, count the number of even integers that's present in the array, and choosing one out of the odd integers. Like say, I'll explain this. Yeah. Okay. So this is a pretty good question that you know. First we read all these numbers, okay, and we will just count whether these numbers are how many of them are odd, and we will naturally calculate like how many of them are even. This is basically a trick to find whether the number is odd or even. AI and A. This is a bitwise AND operator, and ELL even is equal to. So you have to find the number of pairs I and J, AI and AJ, such that AI plus AJ is equal to odd, is odd. So for that, you find the number of even integers. One observation is like plus 4 is 7. So 3 is odd and 4 is even. So odd and even. An odd integer and a even integer together gives an odd sum. So choosing one out of even integers is nc1, that is n itself. So number of even integers is even, so even c1 is even, times, or number of ways of choosing an odd integer is odd c1, that is again odd. This is the answer. So like okay, this is an, okay, I'll just combine this. There are 6 pairs of integers that will give you an odd sum. So similarly, this logic, this is the observation. See, the odd plus even will give you an odd sum. That is the uh, yeah, that's the observation. Like odd plus even will give you an odd sum. Even plus even will give you an even sum. Odd plus odd will give you an even sum. And similarly for product, you can extend this to any product or even bitwise operators like AX or B also. You have to just observe the pattern that's happening out of there. That's how combinatorics is more related to that. There are other things like Burnside lemma and all, Burnside lemma, stars and bars principle, but that's out of the context. So that's all. Is there any doubt or anything that you want to ask?